Hi everyone, my name is Stace, I'm the technical evangelist at Varnish Software, and I'd like to welcome you to yet another video. Today we'll be taking a closer look at cache invalidation in the financial sector and zoom in on how to keep caches up to date for dynamic financial information. Scaling web applications when traffic spikes occur is hard and can be expensive. For a lot of organizations, this involves scaling up or scaling out their infrastructure, and that comes at a cost. In an attempt to mitigate the impact of the traffic spikes, a lot of these companies rely on caching technologies to store pre-computed versions of their content in caches for accelerated delivery. And by using these caches, the pressure on the origin applications and the related infrastructure can drop significantly. This doesn't just result in a better quality of experience and better quality of service, it also reduces infrastructure needs, lowering the operating cost of these applications. By putting an HTTP-based cache in front of these applications, the origin system is only consulted when cache misses occur or when cached content expires. So while it seems that caching as much as possible is the way forward, there is risk associated with caching content for too long, and that especially holds true in the financial industry, where data is expected to be served in real time and where even the slightest delay can result in catastrophe. There's a fine line between caching content long enough to enjoy the desired performance effects and caching for too long, risking potential data inconsistency. And while it seems at first that choosing exactly the right TTL for a cached object is the way forward, the real solution is to explicitly remove the right content from the cache when the changes occur. This being a major challenge for a lot of financial institutions. A lot of them revert back to the old ways of direct access to the application, basically cutting down on caching and increasing the pressure on the origin applications. This increases infrastructure needs, this increases operational complexity, and of course budgetary requirements. And if that wasn't bad enough, there's regulatory requirements in place protecting consumers and mandating that financial data is to be presented in real time. Both in the EU and the US, there's legislation for that, notably in the US, EFTA and Regulation E. And with fines and fees imposed, and in some cases even criminal liability, the benefits of caching no longer seem to outweigh the risks. But luckily there's a solution for that, and as hinted earlier, cache invalidation is the solution. So I'm going to show you how to do that effectively and efficiently using Varnish. Not only is Varnish best in class when it comes to performance, it's also second to none in terms of cache invalidation. But before we talk about that, let's focus on the performance aspect for just a minute. Varnish is extremely fast and stable and used by more than 10 million active websites and 22% of the top 10,000 websites. Our Varnish Enterprise product is currently the fastest content delivery software on the planet, as claimed by Intel based on a benchmark. This is all backed up in a white paper that is published containing all the details. We process up to a staggering 1.3 terabits per second on a single machine, which is extremely fast. But when we switch the narrative from performance to efficiency, that number translates into 1.17 gigabits per second per watt. This reduces the infrastructure footprint, doing more with less, reduces the energy footprint, and of course, reduces the ecological footprint. In situations where outdated content can be identified by its URL, Varnish will use its native purging mechanism to immediately remove that object from the cache. But when the backend is slow and the revalidation process could cause an end-user quality of experience issue, soft purges can soften the blow. Unlike regular purges, soft purges will not immediately remove that object from the cache, but rather explicitly mark it as expired to ensure that the next request for that object triggers an asynchronous revalidation. And while that happens, the stale version of the object is directly served to the end user. And while that further alleviates pressure from the origin servers, it does introduce a level of staleness which might only be accepted for very select pieces of content. Luckily, the tolerated staleness can be granularly configured in Varnish. In situations where multiple objects need to be removed from the cache based on a set of criteria, Varnish Enterprise offers the Y-key module. This module allows content to be tagged and uses those tags to remove multiple objects from the cache using a single action. These tags are user-defined and can be used to either uniquely identify the object or to segment or categorize it. It's just a very flexible way of removing objects from the cache without necessarily being aware of their URL. YKey is built for scale, extremely fast in terms of execution, and very flexible in terms of configuration. It even supports soft purchase, but as mentioned earlier, it's a trade-off and only suitable for content that tolerates a slight level of staleness. There's even a way to perform soft purchase without really relying on stale content. We call these conditional requests. They perform synchronous revalidation to maintain the real-time nature of the content. Under the hood, they leverage Varnish's keep time feature, which keeps objects around just a bit longer even though the content has expired and is out of grace. But the foundation of conditional requests is part of HTTP's built-in caching mechanism, so it's a convention that is supported by most HTTP clients, even the most common web browsers. The way it works is that the origin application sends responses containing an e-tag header. That e-tag header has a unique fingerprint of the content, which is received by Varnish but also by the HTTP client. It is presented upon subsequent requests under the form of an if-none match header and allows both Varnish and the web server to know whether the client has the most recent version of the content. Full revalidations only happen once the data actually has changed. And as long as it hasn't, a 304 not modified status can be returned without any payload. And if the application is optimized for this, the impact of a cache miss on the server resource consumption is minimal, while ensuring sustained performance under tremendous pressure. Thanks to Varnish's native request coalescing feature, the impact of cache invalidations and also cache misses is kept to a minimum. And while cache invalidation aims to provide real-time updates of requested content, these extra requests to the origin are a necessary side effect. Request coalescing, actually meaning merging requests together, coalescing them if you will, ensures that Varnish only sends a single request to the origin, while the requesting clients are queued until the backend response. This takes away the thundering herd effect. And thanks to Varnish's streaming capabilities, the queued clients don't have to wait until the full response is stored and buffered before they can start processing it. As soon as the backend starts responding, the bytes are streamed in parallel to all the queued clients, taking away any kind of latency. And thanks to these scalability features in Varnish, it's a lot easier for high traffic platforms to perform cache invalidation safely. Efficiency is the name of the game here, and so far I've presented various ways to either efficiently invalidate the cache or efficiently reload real-time information after the invalidation. And yet there's one more feature that I want to show you to further optimize the delivery of real-time financial information. When a page is invalidated from the cache, it needs to be fully regenerated at the origin side, even though only 5% of the content has changed. Thanks to ESI, which is short for Edge Side Includes, we have a way of separating dynamic content from the static content. Edge Sides Includes are a conventional standard that are respected by a lot of reverse caching proxies and CDNs. It is in fact an ESI tag that will serve as a placeholder and will load separate content that may have a different time to live. An ESI tag has a source attribute that refers to the resource that needs to be parsed in the placeholder. Varnish supports ESI, and when Varnish sees an ESI tag, and ESI parsing is enabled in the VCL code, it will load the linked resource through a sub-request and stitch the various parts together to return a single HTTP response to the client. Here's why this is such a great way to separate static from dynamic content. First of all, these ESI sub-requests that are triggered, the responses are stored in separate objects with their own TTL. That is potentially a lot lower than the TTL of the rest of the page, forcing faster revalidations. However, you can also invalidate these objects separately to assure that only the dynamic content is affected, while the rest of the page, which could represent 95% of the total content, stays nicely in the cache. Both the open source version and the enterprise version of Varnish support ESI parsing. While the open source version only does sequential parsing of ESI tags, the enterprise version does it in parallel, which is of course a performance booster. Now that you're familiar with the core concepts, it's time to look at the more practical side of things and focus on the implementation of cache purchase. We'll be doing this using the Varnish configuration language, which is Varnish's built-in programming language. We call it VCL. It's not like any other language, and while it shares similarities because of its syntax, it is a domain-specific language that extends the existing flow of Varnish. This flow is represented by a so-called finite state machine, defining the different stages of the execution flow and actions to go from one state to the next. And that's what we'll be doing. We'll be writing some specific VCL code to provide an entry point into the cache invalidation. Here's the first VCL snippet, where we will be performing a native Varnish purge to remove a single object from the cache based on the request URL. We do this by adding some code in the VCL receive subroutine. This is the part of the finite state machine where we will handle incoming HTTP requests. We check whether the request method equals purge. That's how we qualify these requests. So to invalidate something based on the request URL, instead of performing a GET request on that URL, we perform a purge request. And by performing return purge, we transition to the next state and remove that object from the cache. Once the purge is executed, Varnish returns synthetic response. This is output that didn't originate from the origin server, but that was generated by Varnish itself. It follows a standard output template that is part of the VCL synth subroutine, which we could still extend. The output is in HTML format and indicates a successful purge. Of course, we won't leave the purging endpoint unprotected, because otherwise anyone who is a bit tech savvy could send purge requests to any kind of server in an attempt to bring it down. We can do various mechanisms. The most common one is by defining an access control list, or an ACL, which has a list of host names, IP addresses, or subnets that define either a blacklist or a whitelist. We'll opt for a whitelist, so the IP addresses, host names, and subnets in the list are the only ones who are allowed to perform the invalidation. We can add a little if statement to our purge check and check whether the client IP matches the access control list that we call purge. If it doesn't, we'll again return a synthetic response, but not with a 200 purge, but with a 405 method not allowed. Besides ACLs, there's also other ways to protect your purging endpoint. One way would be to use Varnish as an authentication gateway and to require a username, a password, or a different type of authentication to gain access to the purging entry point. The VCL language is flexible enough and has enough modules to cater to those needs. If you want to run soft purges instead of regular ones, you need to import a separate module in your VCL code. This purge module, or purge vmod as we call it, is readily available in the standard installation. It makes the purge.soft function available that takes 3 duration arguments. The first one is the remaining TTL, the second one is the remaining grace value, and the third one is the remaining keep value. You'll typically set the TTL value to 0 to mark the object as expired. And if the content supports a level of staleness, then you can increase the grace value and leverage the fact that the next request will get the old content while an asynchronous fetch happens for an update. If that level of staleness is not tolerated, just set the value to 0 and increase the keep value a bit, so you can leverage conditional requests. This means that if the origin sends an E tag, Varnish will store it and will send if none match values every time the content expires. While the revalidation is, as mentioned earlier, synchronous, the payload can be a lot lower if the response is a 304 not modified. And of course, as mentioned earlier, you can optimize your application to lower resource consumption for that. In terms of implementation, soft purges are similar to regular purges, but there are some differences though. While we're still intercepting requests for the purge method, the rest of the logic is not run in VCL receive. We do a return hash which will look up the object in the cache and will either result in a hit or a miss. If it's a hit, we'll call the custom subroutine, and also when there's a miss. And in that subroutine called myPurge, we'll effectively call purge.soft. We're using a separate subroutine to avoid any content duplication. The output of purge.soft is a number. It's the number of objects affected. That will be stored in this custom purge request header. When the value is 0, we didn't find anything to invalidate and we return a synthetic 404. But when that purged value is greater than 0, then we can say 200 purged. Let's talk about YKey next. I mentioned earlier that YKey can be used to remove multiple objects from the cache at once using tags. Well, this is how you register the tags. You have the flexibility of setting a header that the origin can use to register the tags. So in this case, it's the YKey header. Here's an example of an HTTP response that registers 3 tags. The syntax is free to use. I opted for a prefix with double colons. So in this case, the client ID of this transaction is 1265778. There's also an individual transaction ID for this thing that is obviously a wire transfer. So you're very free to compose a syntax. I took the liberty of using a prefix, double colon, and then the value. This will get registered in Varnish, and then you can use these values to invalidate the cache. Registering YKey tags isn't solely done using the YKey response header. You can also do it explicitly in VCL. So we can add a little bit of VCL code as you see here. For example, check the content type of the response, and if it starts with image slash, such as image slash JPEG or image slash PNG, it's obviously an image and we want to tag it as such. So you can use ykey.add_key and associate the image tag to that object. Once the tags have been associated with the right objects, which typically happens at object insertion, you now have the ability to remove multiple objects at once using one or multiple tags. This happens in VCL receive just like the regular purge flow, and if you look at the VCL code, it's surprisingly similar. There are some differences. We do need to import the YKey module, and we do need to call YKey purge_header, but the rest is the same. We're still checking for the incoming request method and whether it's purge. We're still checking the ACL, whether it's right or not, and we're even providing a fallback. So the tags we use to invalidate are transported using the YKey purge request header. If that header is not set, just do a regular invalidation. But if it is set, use that to perform the invalidation. The output is an integer and is either 0 if no objects were matched, or a number representing the amount of objects purged. And this allows us to return the appropriate synthetic output, either with a 200 or a 404 status code. While Varnish makes scaling easy from a performance perspective, scale does add a level of complexity, especially from a management point of view. The more Varnish nodes you have in your setup, the more purge requests that need to be sent to ensure that the right content is removed from the full inventory. And that's where Varnish Enterprise makes life a lot easier through a set of management tools. First of which is the Varnish Broadcaster, and as the name implies, it's a tool that broadcasts messages. These could be purge requests that are sent to the right Varnish nodes. While it's relatively easy to use and effective, it does require a level of discipline to keep the inventory of active Varnish servers up to date. That's where the Varnish controller is a lot better. At heart, the Varnish controller is a control plane and has a broader set of responsibilities compared to the Varnish Broadcaster. The Varnish controller manages Varnish nodes, and because of its awareness of the inventory, it's an excellent gateway to perform centralized cache invalidation. There's a really nice graphical interface to perform this, and thanks to the built-in API, it's quite easy to implement this and to integrate this into any existing content management flow. I showed you the ins and outs, I taught you the tips and tricks. Let's have a look at how our clients in the financial industry actually leverage Varnish to achieve their goals. Let's start with a US-based asset manager that will remain nameless for now because contractually we can't mention their name. Their website is actually the face of their company. And previously they didn't really focus on caching too much HTML and API output. But their goal walking into this was to reduce hosting costs and also to significantly reduce page load times while increasing end user quality of experience. Just like most financial institutions, they were faced with compliance regulations, requiring them to serve up-to-date content to avoid any enforcement actions. In the process, they updated their CMS and applied a more modernized technology stack, which blended well with Varnish and the implementation of cache invalidation. The caching and the personalization on the edge, thanks to Varnish, allowed them to improve their Lighthouse score, which is a great indicator of website performance and perceived loading speed. That same US-based investment company also heavily relies on MSE, which is short for the Massive Storage Engine. This is our proprietary storage component that is built for scale and performance. They use it for resilience because of its persistence capabilities and of course also for large-scale distributed cache storage. In conjunction with that large-scale storage, they also use YKey, which is our proprietary tag-based invalidation component. It works really well with Massive Storage Engine because it's optimized for scale. So that means YKey doesn't just give you the granularity of tag-based invalidation, it's also very fast and keeps on scaling even with petabyte-size workloads. They're also a heavy user of ESI for cache personalization on the edge, and they really benefited from Varnish Enterprise's parallel ESI capabilities, ensuring that static and dynamic content are nicely separated. Their Varnish setup doesn't run as their sole CDN. It's a multi-CDN effort, and our tools and our management suite needed to be compatible with that, which we were. Some of the client's data tolerates a level of staleness, however they want very tight control over that. And they can do so using native Varnish features as well as some enterprise vmods. They use staleness for revalidation, as a lot of people do. They keep serving outdated content while the new content is asynchronously fetched. But they're also using it in case of outages, so when the origin application is not available for certain very specific types of data sets, it is better to serve the old data than to serve an error message. Because cache invalidation is so important to them, they want to centralize the management and provide a single interface to perform distributed cache invalidations. And they're doing so through the Varnish controller. For the next financial use case, the client can be named. It's a French bank called Boursorama, and they use Varnish very intensively. They use a multi-tier caching setup, where they separated the various tiers in their application flow. So there is a Varnish layer for their website. There's a separate Varnish layer for the API output that needs to be accelerated. And their data access services are also protected by Varnish. Their improved Varnish efforts, especially at the lower tiers in their multi-tiered caching setup, and their efforts to improve the hit rate allowed them to take the pressure off CRM systems, partner services, and databases. They even use Varnish to offload their API authentication layer that uses JSON web tokens as the authentication and authorization mechanism. Because Varnish can validate those, Varnish could turn otherwise uncacheable data into cacheable data, making Varnish more of an authentication gateway in that very specific use case. The way Boursorama offers real-time financial information to their clientele, while still maintaining a decent level of caching, is a mixture of setting the right TTL and performing cache invalidations. They estimated that personal data of their clients rarely change. So names, addresses, and similar parameters can be in the cache for a long time and can have a very high TTL. They also estimated that on average people do rarely more than 10 banking transactions per day, which justifies a medium TTL. And while wire transfers outside of the bank can tolerate a certain level of delay, for wire transfers within the same bank or instant payments that is not acceptable, so they rely on purging quite heavily. Boursorama is a heavy user of ESI. Some pages have even more than 15 ESI tags. ESI helps them to achieve a 95% hit rate. As mentioned earlier, it allows a lot of financial clients to separate dynamic financial information from the static content. They even share certain content blocks loaded through ESI tags on other pages. And they implemented a level of graceful degradation of ESI placeholders in case of failure. So it's better to lose 5% of the content in a single ESI tag than let this bubble up to the entire page and have a complete outage. Of course, they need parallel ESI with the level of ESI tags they're producing, and they do hundreds of cache invalidations per second. Our next use case is with Morningstar, a client of ours and a US-based investment research firm. As the customer case states in the headline, fresh data is vital for Morningstar and their customers. And their requirement was to have a minimum of 2,000 cache deletions per second. Anything below that was not acceptable. We took those numbers and went to work with them as a minimum requirement, and our tests showed that we could perform more than 60,000 cache invalidations per second, which is absolutely massive. However, in a more pragmatic context, they wanted to run cache invalidations on smaller infrastructure footprint with limited virtualized hardware. And that still yielded double of the minimum requirements, 4,000 cache invalidations per second. This needed to be very fast and very consistent over globally distributed caches. And these invalidations allowed them to set higher cache TTLs. Despite a high rate of cache invalidations, their hit rate went up from 70% to more than 90%. And from a security perspective, they added extra hardening measures to protect the purge endpoints with a combination of HMAC signatures and access control lists. They also needed a centralized invalidation endpoint that they can use to effect global cache invalidations, and that was used through a RESTful API. They also relied on Connection Keep Alive to make efficient use of open connections, especially in the light of that high rate of cache invalidations. The last client I'm going to feature is Credit Suisse. It's a Swiss bank that offers thousands of static and dynamic pages on their web platforms. Just like all the other financial institutions, there's regulatory oversight requiring them to serve real-time data to their clientele. They wanted to replace Adobe Dispatcher, their old caching system, and get something that has more flexibility and performance. They opted for Varnish, of course. They wanted to integrate Varnish into their existing CDN and use us for finer-grained cache control, and also to streamline cache invalidations across the multiple CDNs, which we can. And through the use of Varnish and efficient invalidations and setting higher TTLs, they increased the hit rate from in between 50 and 65% to between 90 and 95%. The goal for Credit Suisse was to lower costs, and they noticed that using Varnish they could lower the cost of serving content on the edge compared to sending all the traffic to the backend servers. They also wanted a faster time to market and concluded that scaling Varnish servers is a lot faster and easier than adding backend servers when capacity increases are required. There are also a heavy use of the cache control headers, which are conventional HTTP headers that we support, and it allowed them to choose the right TTL for the right job and make it very portable in their applications. And that's it, that's the end of the video. Thank you for watching. I hope you learned a thing or two in the more practical part of this video, and I hope the customer cases inspired you. My message for you is, despite being in the financial industry and being under regulatory oversight, that caching should not be a problem and is the way forward for a lower infrastructure footprint. Cache invalidations are the real savior here, but in conjunction with other caching mechanisms, you can leverage it to the max and ensure that you can serve real-time financial information while still maintaining a decent level of caching. Again, thanks for watching, and I'll see you next time for another video.